if we get through them.
And we don't have a lot of questions.
All right, here we go.
I need to get knowledge.
Binomial probability. Let's take a quick review from what we did on Friday. Quick review. They are repeated situations called trials. Each one is a fixed number of trials. So, that could be flipping a coin 10 times. It could be rolling a die 25 times. Right? It could be any sort of thing a certain number of times. So it means by a fixed number of trials. For each trial, there are two possible outcomes, success or failure. Right? For a coin, it could be flipping a heads, flipping tails. For a dice, it could be rolling a 6 and not rolling a 6. There are only two possible outcomes for each thing. Probability of success is the same in each trial. Right? So that means it is an independent event. It doesn't matter what the probability was the first time, it doesn't affect it the 4th or the 10th or the 20th time.
Or the
They're
millionth.
all independent events. Now, those were all features of exact probability. Right? That's what we did on Friday. We did exact numbers. I want to flip a heads exactly 3 times out of 6. I want to roll a 6 exactly 5 times out of 10. Now, what about if we're computing at least or at most probabilities? So instead of saying I want to flip exactly 3 heads, I want to flip at most 3 heads out of 6 flips. What can I flip then? How many can I get? I can get 0, 1, 2, or 3. Right? So we're going to have more calculations now. When we compute at least or at most, it's necessary to consider in addition to the given probability. So if it's at least, so if I want at least 3 6s out of 8 rolls, I can get 3, 4, 5, 6, 7, 8. Right? I can get anything more, that or more. Probability smaller would be like at most, like we said. At most 3 heads out of 6. So 0, 1, 2, 3. Then what we're going to do is we're going to add all those probabilities together once we find them. Alright? So we're going to do our equation multiple times, and we'll add all those probabilities together. Let's try some examples. The first one's an exactly problem, like what we did on Friday. So, probability that Kylo will score above a 90 on a mathematics test is 4/5. What's the probability she'll score above a 90 on exactly 3 of 4 tests? So exactly 3. Right? So n equals 4, because there's 4 tests. R equals 3, because I want her to score above a 90 on exactly 3 of them. What's my probability of success? 4 out of 5, right? 4/5, which means my probability of failure is going to be 1/5. Good. Then I'm just going to plug that into my equation. Right? So NCR 4C3 times my probability of success, 4/5, to the 3rd power, or the R power, times my probability of failure, or 1/5, to the n minus r, 4 minus 3 power, equals 1. I'm just going to plug it in my calculator. Now I'm going to write it out as a decimal first, and then I'm going to change it to percent.
41.
0.4096, which is approximately, what? 41.0%. Alright? That wasn't so bad, was it? We know how to do that. That was our Friday. That was our lesson on Friday.
Well, here's where it gets harder.
Here's where it gets a little more challenging. Right? It's not that bad. It's an at least. So we're using the same stipulations. Probability of Kyla scoring above a 90 on a math test is still 4/5. Probability that she'll score above a 90 on at least 3 of 4 tests this quarter. Well, I'm still taking 4 tests, so n equals 4. But what does my r equal now? What could my r equal?
3.
I could have 3. I want at least 3. So I could be 3 or 4.
Greater than or equal to 3?
Greater than or equal to 3, right? 3 or 4. Because I'm only going up to 4. So r is going to equal 3, and it's going to equal 4. And I'll show you how we do that in a second. So probability of success is still 4/5. Probability of failure is still 1/5. Now, how we're going to do this is, we're going to let r equal 3, and we're going to plug it into our equation. We're going to let r equal 4, and we're going to plug it into our equation. We'll Hold on a second though. Didn't we already do r equals 3?
Mm-hmm.
Yeah, so I'm just going to take the decimal that I already have. I'm going to use that. 0.4096. It doesn't make sense to do it again if I've already done it once. Right? Just use that other one. It's the same stuff I'm going to put in my calculator, but I did it once already. Then I'm going to do where r equals 4. So I'm going to get 4c4 times probability of success, or 4/5. I want to succeed 4 times, or to the r power, so the 4th power, times the probability of failure, 1/5, to the 0 power, or the n minus r power, or how many times I want her to fail. In this case, 0 out of 4 tests. What do I get when I put that in my calculator? Same thing, 0.4096. What did we say we're going to do with those two? We're going to add them. So I'm going to take this one. I'm going to add it with that one. And that'll be my probability. So we should get 0.8192, or approximately 81.9%. Remember, I may practice rounding to the 10th place with a percent. Just me.
Okay, that's easy.
Yes, Kaylee.
I don't understand why you did it to the 4th and to the 0.
So because I have probability of success to the r power, what does r equal? 4. So this is the 4th power. Probability of failure to the n minus r. Well, n equals 4 and r equals 4. So 4 minus 4 is 0. Another way you can think of it, the way I like to think of it, makes it easier to remember the equation a little bit more, is how many times do I want her to succeed, or how many times do I want her to get above a 90? 4. So that's how many times the probability of success is going to be used. Then we want her to fail 0 times. Okay? Either way works. Any questions on those? 2 more problems. A bag contains 6 red bingo chips, 4 blue, and 7 white. What's the probability of drawing a red bingo chip at least 3 out of 5 times? Well, n equals 5, because I'm drawing 5. R is at least 3. So R could be 3, 4, or 5. Probability of success. What's my probability of success going to be? 6 out of 17. How'd you get that, Aaliyah?
Because you add the 6 bingo chip, like all the bingo chips together, and then there's 6 out of all of them.
Perfect. We need to add all the different bingo chips we have. We have 6 red, 4 blue, 7 white. That gives us 17 total chips. And I have 6 red, so 6 out of 17 for picking red. Which means my probability of failure then is going to be what? 11 out of 17. Right? So you can think of it as picking anything but red. Well, there's 4 blue and 7 white, so that's 11. Or you can think of it as, I know probability of success and probability of failure need to add up to 1. So I could do 1 minus 6 over 17 and get my failure. Alright? So I'm going to let r equal 3, r equal 4,